Hello everyone, in this video I want us to look at the quadratic formula, which is another method of solving quadratic equations. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Again, remember the a, b, and the c here come from the standard form of a quadratic equation of ax squared plus bx plus c equals 0. So in order to solve using the quadratic form, we need to be able to pick out the a, the b, and the c. Now, before we actually get into solving the quadratic formula, I want us to just look at this part underneath the square root, this b squared minus 4ac. All right, this actually has a name called the discriminant. And what this allows us to do, this discriminant, is we can solve this discriminant and figure out how many solutions an equation will have and the types of solution that an equation will have. So let's look at an example. Let's say we have 30x squared plus 21x plus 3 equals 0. Now, what I want us to do is use the discriminant in order to determine the number and types of solutions. So we're going to plug it into b squared minus 4 times a times c. So b squared, so that is 21 squared, minus 4 times the a times c. All right, so 21 squared gives us 441. And then if we do 4 times the 30 times the 3, that's going to give us 360. And then if we do 441 minus the 360, that gives us 81. Now, because I got a number that is greater than 0 for my discriminant, that tells me that I have two real solutions. Okay, so I'm going to have two real solutions. Now, because my answer was what's called a perfect square, meaning that the square root of 81 is 9, it's a perfect square, we can actually take this a step further and say we have two distinct rational solutions. All right, so we found the types and the number of solutions we have using the discriminant. All right, let's try another one. So let's say we have, again, we're using the discriminant to determine the types and number of solutions. So we have x squared plus 7x minus 1 equals 0. Again, only focused on discriminant, b squared minus 4 times a times c. So b squared, that gives me 7 squared, 4 times a, which is 1, times c, which is negative 1. Well, 7 squared is 49. Negative 4 times 1 times negative 1, so that turns positive. Negative 4 times 1 is negative 4 times a negative 1, gives me a positive 4, which gives me 53. All right, so again, because this is greater than 0, then I know we have two solutions, two real solutions. But if we notice here, so we know we got two real solutions because it's greater than 0. But unlike the last problem, 53 is not a perfect square. So instead of two distinct rational solutions, we will have two distinct irrational solutions. All right, let's do one more, just solving using a discriminant. Negative 3x squared minus 5x minus 8 equals 0. Alright, so if I take my discriminant, that is negative 5 squared minus 4 times a times c. Well, negative 5 squared is 25. And then we have negative 4 times negative 3 times negative 8. That's going to give me a negative 96. Again, we have negative times a negative times a negative. So it leaves me with a negative number. This is actually negative 71. Now, because my discriminant is less than 0, then this tells me I have two complex solutions. Right. And if your discriminant was to equal 0, so if we had our discriminant and that equals 0, well then that tells me that I have one real solution. Alright, so this is just a part of the quadratic formula, the discriminant, which allows us to, again, find the number and the types of solution a quadratic equation will have.